Is it possible to take the irrational evaluation of pi and create a whole evaluation? Ladies and gentlemen, welcome to Second Earth Alternative. This is a really exciting episode. Only thing, it hasn't been so exciting from Second Earth's perspective lately. We shot this episode about 2 weeks ago, and if you're wondering what's taking so long to bring these episodes to the public, well, it's basically this unbelievable type of censorship that has been happening, kind of like an aggressive interference. And although it might be easy to establish a type of Occam's razor, I want to make it very clear that this channel has been threatened twice. So even if I were to try to use Occam's razor, it would be difficult to ascertain exactly who it is. Not to mention that the type of sophistication that we're talking about yields to the possibility that these attacks have been happening from a revolving door circumstance. I want the audience to refrain from making allegations before we can actually put the pieces together. And if you want to know what the interferences are like, well, take a look. Okay, but having said that, I want to bring this episode back to the positive land, so to speak. Happy Gilmore is a happy place.
And he's having a good time. Good for you. Yeah, laugh it up. Enjoy your night. Ha ha ha.
Come on, Happy, concentrate.
So what I want to do today is go over some of the topics related to pi and how to possibly close out pi to the numeration of 5 and do so at an extremely high precision. Although it may not be completely closed out, at least not yet, I believe it might be possible to go past this conception of transcendental numbers. Now, what do I mean by this? Well, the transcendental numbers are numbers that don't end. There's always a type of engine that's happening that allows the numeration to keep going. And that's what pi stands for. But something that became apparent with time, the more that the mathematics was evolving, was that perhaps pi can't do everything on its own. So if I were to create a circle, for example, we know that pi can represent the circumference of a circle if we have a radius of a base unit 1. But what happened if that circle was three-dimensional? Well, we also can evoke pi with a volumetric formula. But what I find so interesting is that the way that the universe works is that there are going to be these moments of singularities. So imagine you're falling into some kind of black hole. Wow, that's just not a black hole, but we'll go with it. And when you enter this type of singularity, eventually it gets to a point where it's just a single, almost one-dimensional presence. And when we think about the golden ratio, and this is the symbol for the golden ratio, which is 1.618033 and ongoing, the golden ratio can actually evoke a one-dimensional existence because the quadratic equation of the golden ratio, if we call it f of a equals a squared minus a minus 1. Now, because f of a is 0, the reality is that the golden ratio never truly reaches any of its definitions. So I could say that, for example, that a squared minus a equals 1, or I could say that a minus a squared equals minus 1 if we establishing the quadratic equation of the golden ratio. But that 1 and a negative 1 aren't actual equal signs. I mean, we use it to evoke what it should be approaching to, but I think that's the key, that the golden ratio approaches to these forms. It doesn't actually equate to it because the golden ratio is infinitely iterative to its own construction. When we represent the golden ratio as a f of a equals a squared minus a minus 1, what we're really doing is establishing an identity of the golden ratio that allows the root structures to define the presence of the golden ratio itself. The root of this quadratic equation is going to be either 1.61803, but it could also be minus 0.618033, which represents the negative conjugates. And if we were to multiply the negative conjugate by minus 1, for example, well, that would equal 0.618033. And amazingly, that is actually 1 over the golden ratio. And I think that's what I meant by it's infinitely iterative, because its own forms become self-reflective to its construction, so that I can, for example, say that a plus 1 equals a squared. In other words, a squared, the golden ratio squaring to itself, can be constructed by simply adding 1 to itself, which equals 2.618033. So I'm going to go over more about this in the more detailed lesson that I was not able to edit. What I wanted to showcase is another way of establishing the golden ratio that doesn't require numeration. And that is a very simple construction of simply taking a segment, let's call the segment AB. And if we were to have, let's say, some type of slider, and this slider can move either left or right, well, the golden ratio is going to be the exact point where you adjust that slider, so that if we call this slider B, let's call this one C, make it easier. So if we call this slider B and we have the segment AC, what's happening is that the golden ratio is going to be the exact position in that slider where AC, accounting for the whole, divided by AB, which is going to be the bigger segmentation, it's going to be where that equals AB over BC. In other words, the golden ratio is the exact point of equality between the whole form to the bigger parts and the bigger part to the smaller part. But this is kind of strange, and this is something that mathematicians, or at least I haven't heard talked about very often, which is that nature doesn't really work like this. Nature can't measure a whole if it has already segmented itself. In a way, it's kind of like implying a type of before state and an after state. So if we can construe the whole, let's say this was a chopstick. So this chopstick, if we break it at exactly where the golden ratio is at, just like we did with the slider, well, to get the golden ratio, we would have to take the whole chopstick, re-glue it together, break it again, and then measure it. So in other words, it's kind of a self-reflective definition that requires a folding of time. Before I show you what that means, I want to first go over a very important numeration, which is 432. Now 432 is actually 6 cubed times 2. And 432 ends up being not only a sacred number, if you ever heard Randall Carlson speak, but 432 also represents the number of iterations forwards and backwards that we're able to establish in the unity formula that we introduced in the first episode. And if you haven't seen what that looks like when it's being iterated in Blender, well, take a look. So this whole conception of 432 is something that we're going to go over in a lot more detail on the other lesson that I wasn't able to edit. But I wanted to at least establish the importance of this numerical evaluation. So outside of 432, in general, the type of ideas that we're going to be exploring in this theoretical framing is the idea of a mirror universe, one where entropy can run backwards and be paired with dynamic systems. Professor Neil Turok's idea of a mirror universe, this is a conception that I had in parallel, only finding out weeks later that there was other theories related to this very idea. In essence, I'm also assuming an informational universe, one where the informational integrity or type of virtual presence becomes just as important as the real presence. And it's also kind of assuming a holographic presence. If you ever read the holographic universe, the ideas are very close to that conception that maybe we are in a type of hologram, though I wouldn't say completely matrix 100%, more like a quasi-real, quasi-virtual presence. And probably the thing that I wasn't certain about, but the mathematics seem to lean that way, well, it's this concept that the universe might be based on dynamic systems and it might require a synergy. For example, if you take a look at this 432 formulation, you will notice that the way that we evaluate the identity of these irrational constants and even universal constants, it's not just the result of a formula, it actually becomes a bridging of a real world and a rotational world that is essentially swapping each other's evaluative forms such that the actual evaluation of each iteration in reflection to the real plane and the complex plane becomes a formula that uses the golden ratio as a type of codec for the universe. And so the actual identity becomes the placeholder for the variable of these formulaic structures. And in a way, I think of this as kind of like a way of interpreting mathematics with a backwards entropy. You're not finding a value, you're finding where the identity of the form is effectively taking the variable of a template that the golden ratio establishes with these complex plane and real plane constructions. And this is actually something that we showcased previously with the fine structure constant formula, because if you look at the fine structure constant formula, you realize that the variables are actually exchanging between the RE, which stands for the real plane, and the imaginary plane. And the imaginary plane, if you don't know, it's basically I stands for the root of -1, which from a rotational dynamics is established by a 90-degree rotation. Again, these are concepts that I'm going to go in a lot more depth in the follow-up episode when I actually am able to edit properly. So for now, I just want to quickly introduce some of these ideas, and also the idea of magic 54. There's this really interesting property about 54, because not only does it stand for 540 degrees, if we can establish a 10 times sliding scale, so to speak. 540 is the double of 270, so 270 times 2 equals 540, and 270 is 3/4 of 2 pi. And I say 2 pi in radians, so that means that it can account for 3/4 of a spin around a circle. But if it's 3/4 of 2 pi and that's doubled, then it becomes 1.5 rotations for 540. But what happens if we don't have to worry about the zero? Then 54 becomes integral, because it becomes the informational integrity necessary to describe this dynamics. And I'm going to show later on why this is possible, because effectively what's going on is that when you segment or partition it into 360 degrees, that's an arbitrary but not really arbitrary form.
Maybe we could just get together and eat a bunch of caramels.
What do you mean?
When you think about it, it's as arbitrary as drinking coffee.
Yeah.
And the reason why is because the circle has an infinite amount of potential partitioning. Like, you can dissect it in an infinite amount of ways. But we establish a 360 degrees as an arbitrary form that has properties that it carries that simplifies a lot of our mathematical forms. So for example, 360, if I can go back up over here, 360 is 3 powered by 2 times 2 powered by 3 times 5. So we've taken the even and odd forms and we've switched their placements in terms of an exponentiation, and then use them as factors to get to a total of 360. And what's the deal with 5? Well, what's interesting about 5 is another way that we can establish the golden ratio. And first, let me make the point that when we do establish it by simply finding the point in the segments, it's not really evaluative. The golden ratio is a proportion. It's basically saying where two proportions can have equality to each other. Because although I can establish that the golden ratio might be at the exact same points relative to this AC segments, the AC segment doesn't have a unit. Well, at least not yet. I can make the AC either meters or maybe centimeters or maybe kilometers. So regardless of what metric I choose, the golden ratio, well, it's still going to be the golden ratio relative to itself. It's kind of a self-relative proportion. And so another way that we can write the golden ratio is by writing root 5 over 2 plus 1/2. And that does equal the golden ratio. But what's really interesting about this identity is that if you're to take a triangle and you're to split it into the units of 1/2 to 1, so let's say this is a 1 unit leg and this leg is only 1/2, well, the hypotenuse is going to have to be root 5 over 2. In other words, the hypotenuse, which is this guy over here, so that would be just like 1 squared plus 1/2 squared equals hypotenuse squared, but 1/2 squared is 1 over 4, and so 1 plus 1 over 4 becomes 5 over 4, but the square root 5 over 4 is root 5 over 2. So we can see that the hypotenuse has to be root 5 over 2, but if the golden ratio is root 5 over 2 plus 1/2, then what we're really saying is that when we establish a 1 to 2 ratio and we make that 2 actually the equivalency of a 1 unit form, so that just means that the 1 is twice as big as the 1/2, then the golden ratio can also be defined as that type of triangle and having its shorter leg, 1/2, added to its hypotenuse. I think this is phenomenal because it just allows you to kind of see the golden ratio in these multiple different forms. You can think of it as how it bisects a segment, or you can think about it as being additive forms of a particular side of a triangle plus the hypotenuse. But what I really want to get to is the idea that the golden ratio is actually being able to fold time. We established that the f of a of the golden ratio for the quadratic form equals a squared minus a minus 1. As I said earlier, that just means that this quadratic form is going to have the roots of the golden ratio, or 1 over the golden ratio minus, which becomes the negative conjugates. But I think something that a lot of, well, at least I haven't heard this in a lot of mathematics courses, is that the golden ratio can also be established as a rotational dynamics. So if I were to take the sine, and this is where we're going to come back to that very critical 54, I like to call it magic 54, and I'll explain to you why it's such an interesting number. But the sine of 360 minus 54, which becomes 306, plus the cosine of 432 divided by 2, which becomes the cosine of 216, and I should add that 216 is also 4 times 54 degrees. So all of these are equal to each other. So let me just rewrite this to clean this up a little bit. So the sine of 306 degrees plus the cosine of 216 degrees, ladies and gentlemen, that equals the negative golden ratio. And since we know that the f of a equals a squared minus a minus 1, well, minus a is right here. Those are one and the same. But if minus a can be represented as rotational dynamics, what happens if we were to switch the numbers or the functions to each other? Well, amazingly, if you take the sine of 216 degrees plus the cosine of 306 degrees, well, that equals 0. Now, think about this for a second. What we established is that not only can we write this, instead of 306 degrees, we can write this as 360 minus 54, which is a type of time inversion. If we can establish 54 as a basis for this construction, we know that 216 equals 4 times 54. So that becomes at 306 degrees, and that becomes the 216 degrees. It's incredible because we can establish a new function for the golden ratio where by switching the degrees, so we have the sine of 306 degrees plus cosine of 216 degrees becoming the negative golden ratio. So instead we do the sine of 216 plus the cosine of 306 degrees, we get 0. Because the f of a of the golden ratio equals a squared minus a minus 1, the a squared takes precedence before any other operation because it's an exponentiation form. So if nothing has been established, and we just talked about how the golden ratio is self-reflective and thus might require another form to establish the unit to which it can equate the proportions of, in essence, the golden ratio can't really be defined as minus a until we already establish a squared. But if minus 1, which can be a composite of 2 of the other forms itself, so we know that minus 1 equals a minus a squared, these are, you can see that it's a compound function. There's 2 constituents or 2 parts that make up the minus 1. So if somebody were to ask me how many functions are established within the quadratic form of the golden ratio's construction, I would say 2.5, because you have the a squared as a function, minus a as a function, and minus 1 as, well, kind of a half function, right? Because to actually utilize the minus 1 in a constructive way, we would have to have, like, for example, a squared equals a plus 1. So the 1 as a standalone form, or minus 1 as a standalone form, is kind of like a half of a function relative to the golden ratio. So although looking at the quadratic form, the golden ratio seems to have 2.5 functions, we have to realize that the f of a is 0. So if the f of a is 0, then the golden ratio has 2.5 functions, but not until something is established, like the a squared being established, can we then say, oh, well, now we have a minus a that can be constructed, and that creates this identity that we just discussed. And so the minus a identity, only when that is present can we then infer the ability to inverse the numerical numbers. I guess what I'm trying to say is that the golden ratio seems to have 2.5 functions in 2 different moments in time. When it's first established as a quadratic equation of a squared minus a minus 1, and then after a squared has been effectively evaluated, we can then say that minus a equals this form. So minus a becomes also a rotational dynamics, and only when that rotational dynamics is established can we then infer the ability to switch the numerical forms to create 0 as a new function. And I think what this really implies is, because there's an order of operation that has to happen with a squared first, that the golden ratio is effectively folding time. At least that's how I interpret this. And what's pretty amazing is that this 54 can actually put into a function as a kind of like a resonant function. So let me show you what happens when you try to resonate 54 with half of itself, 27, in a functioning form. Okay, so now that we got the concept of the golden ratio possibly being a time folding function, something that started becoming apparent to me is that maybe the actual conception of awareness itself could be like a time inverse process. Now, if you talk about psychology and neurosciences, professionals will tell you that the way that the brain works is that it's initially inputted 2D information, and that 2D information becomes, how do you say, I guess, three-dimensional, but it requires a type of processing that happens. But right around the age of 3, 4, maybe around 5 years old, after object permanence takes place around 3, there's a gap where young children are not really able to see in 3D. Their brains have to model the universe and I guess in a way almost simplify its presence from what might look more like a 2D static information that is more contingent on linear lines. Merging the 2D input create a 3D rendering inside the mind. And that's really important because people forget that we have two different worlds. We have the post-memory world where our memories effectively are able to anchor the awareness and the constructions that we have into a three-dimensional understanding. And then we have the pre-three-dimensional, pre-object permanence kind of infant world where the actual form is quintessentially different, I would say. And then comes how to evaluate pi to 5. This is a difficult topic to breach because some of these insights are coming from what I would say is kind of like a non-linear thought process. It's not hocus pocus because it's happened before in our history. If you look at the Pythagoras, for example, Cantor, even the mathematician who won the Fields Prize but decided not to take the $1 million prize. And as many of you may know from movies like Good Will Hunting, there is Ramanujan.
You wanted to know how I get my ideas? My God. I'm kidding. She speaks to me. Puts formulas on my tongue when I sleep.
I don't
Sometimes
want
when I
to
pray.
breach the topic of religion because I am afraid to offend people who may not have similar perspectives. But without trying to infer that my mathematics is nearly as strong as Ramanujan or that my work has established anything close to him, I wanted to at least lay out the ideas that some of these forms did come from what I call non-linear insights. Insights that effectively came in dreams. Sometimes they would come in deep meditation sessions. And yes, there was a sensation or a feeling that where this came from had a type of intelligence or intellectual integrity in its own form, as if I was being guided to these concepts. So one of those forms ended up being the construction of 12.7543 divided by pi. And what ended up happening is when I started playing with this form, I was able to close out pi to a rather significant, precise evaluation. Now, if you do it with most regular calculators, it's going to say it's whole 5. And what's amazing in my perspective is that although it looks like whole 5, if you were to put it in a precision calculator, at least the ways that I've constructed this formulaic structure, as you can see in the image, that exact evaluation can probably get up to around 23 decimals. But I think there's something here, and it has to do with how pi might require help when we're talking about a one-dimensional singularity presence, that the golden ratio kind of spaghettis itself into as it approaches 0, because although the amount of coilings that the golden ratio can stand for reaches infinity, the actual dimensional presence of the coiling, like a frequency getting smaller and smaller and smaller or tighter, it effectively kind of turns into a line. And so that one-dimensional presence, pi can't represent that. So how is pi going to be a transcendental number if the dimensions collapse or at certain points become singular or reach a type of singularity at one-dimensional presence? I think the key, ladies and gentlemen, is what Dave Matthews calls the space between. this would be effectively the fine structure constants. Because this fine structure constants, although in physics it's considered to be the evaluation of the electromagnetic forces that interplay with elementary particles, and it stands for, if I were to write in a decimal, it's around 0.007297325643. What I found incredible is that, first of all, the fine structure constants, when we map it, we see that it's borrowing from both the real plane and the imaginary plane, as if it becomes a type of space in between dimensional forms that transfer from a rotational dynamics to a real world plane dynamics. And looking at the graphical input, you see that it takes a type of kind of like an inverted logarithmic curve, but it does so that the real plane and the imaginary plane, if I can divvy these right through the middle, they act on each other's presence so that their self-canceling nature becomes invariance to this. So it's like kind of like an invariant space in between that will always be the exact proportion, because I think you can also write it as 1/137 in approximation, but that does become invariance no matter where you are in the x-axis of the graph, because they relate with each other's presence. So even when you're shooting up over here, this same thing happens with the complex plane in such a way that they take each other's variable to calculate to our fine structure constant. Now, what I believe that means is that the informational integrity of curvature itself was bifurcated in 2 dimensions, and I believe that the curve carries the informational integrity to re-establish pi's own nature, where pi is unable to reach because pi has to be at least a 2-dimensional form. So I think when I was theorizing this possibility, in a way it was a surprise, like I nearly fell off my chair, because I was like, oh my gosh, there it is, like, eureka, like, you know, it was like one of those moments, right? Because what happened is, when I formatted this exact formula that can calculate pi to a very, very high precise level, look what happens when we change just a few of the forms and then subtract the total of that formulaic structure by 5. As you can see, it's the fine structure constants exact. Given pi's transcendental presence, I don't know what to make out of this other than to say that this seems highly significant, and I wanted to share this to the public in case that individuals who have much higher mathematical acumen, although I tutored SAT and ACT math, I technically didn't graduate with a math degree. So what I wanted to do is share this to the public to see if the public could take this construction or something similar and maybe adapt it, maybe make it more cohesive, maybe simplify the formula in a way that becomes more applicable to either physics or other disciplines of mathematics that I may not engage with it with the specificity that they could. And just to give a teaser for the next episode, we will be using, ladies and gentlemen, primes to also calculate pi. So there is a way to close this out or get to a very high precision, just like this variation of the formula that gets, I think, up to 23 decimals of closing out 5 to nearly a whole valuation. But in this case, what we're gonna do is we're gonna take the actual prime counts and use the counts of the prime as a indicator or a mathematically applicable construction. So for example, the 235th prime, which if I were to subtract 235 by 100, I can get 135. And if I multiply 135 by 2, you see that that is our 270 that we discussed earlier. That stands for 3/4 of 2 pi radians. In other words, 3/4 of a circle. If we do take the 235th prime, which is 1483, and we divide that by that very important 432, and we subtract that by its own inverse. So effectively, we're really just using 2 numerical numbers, the 235th prime and our 432. So by subtracting by the inverse of that, This, ladies and gentlemen, is going to be an extremely close approximation to pi, but most importantly, I believe there is a way to close this out using rotational dynamics that could help us redefine prime numbers in a way that, at least from what I've researched, I really haven't seen it being done like this before. So this is going to be a very exciting episode, and it's important to know that the golden ratio, just as a last pointer, it kind of rests itself around the constructions of 0.618033, and then that is its inverse, but if you add it by 1, then it becomes the 1.618033. But if you look closely, you'll notice that we have a very important 0.6 form, and then we have 180, which 180 becomes half of 360 degrees. Now, obviously, you have to divide 180 by 10,000 to be able to how the golden ratio or its inverse defines it. But just to say that these 6 base forms in the rotational dynamics that we're accustomed to with 360 does seem to present itself within the golden ratio construction. And it's worth noting that if we were to take 6 powered by 4 minus 6 powered by 3, that equals 1080, which not only matches this exact graph where ChatGPT and I tried to match the potentiality of a dual universe and whether it could actually be possible to have a shared entropy paired system. Well, it's worth noting that not only does it cross at the golden ratio, when you talk about the gravitational potential, it crosses at that 1.080 form. Seems rather significant, especially since 1080 is 3 times 360 degrees. All right, ladies and gentlemen, this episode, although it seemed long, was actually kind of a brute, down to the points. Let's show you what we got going over here. And I hope to expand this with a much better mathematical approach, so long as the powers to be who are interfering allow so. It's amazing that it's come to that, but I'm so happy that you guys made it this far. Thank you so much. And if there is a way to combat censorship or shadow banning or whatever might be taking place that is disrupting this channel, well, you know what to do. This is Felipe speaking, signing out.